Good evening, all of you. Welcome, you guys. Welcome, you all. So, welcome, you guys, and all of you do join the sessions. Everybody, welcome to this live session. And so, as we are starting the digital Barfi series, in this series we are doing all the PYQs, and we are completing all the DPP problems of digital. We are completing. So, all of you do join the session fastly. Yeah, first of all. And so here, tell me now here, is my audio video is clear to everybody? Is the audio video is clear to everybody? Will you please comment? Yes, जल्दी comment करके बोलिए. अगर audio video is clear है तो बोलिए. Then we can start our session. चलो. The last class we have completed some of the problems, and let's continue the remaining problems. Let's continue the remaining problems. And before this, we have the great announcement you can have. Look at here. And so we are doing the special class festivals we are doing. In this thing, you can find the top educators will taking the problem discussion, most important concept we are discussing for the GATE 2024 के लिए, right? And you will learn from the top educators, directly talk with them, interactive polls and doubt sessions. And these are the sessions I am planning on this thing here. First 3 classes will be on the YouTube. Next 3 classes are in the special classes. Digital Barfi series 3, 4, 5, 6 will be at the 6 p.m. 4, 5, 6. ठीक है? चलो. And these are the new batches we are starting. You can have a look at now here. And right now the digital is running now here. You can find the top educators. I am starting the DLD, digital logic circuits, for ECE, electrical and instrumentation students के लिए है. This is for GATE 2024 as well as 2025. And you can have a look at now here. To enroll for this thing, you can use a code of BVReddy. By using the BVReddy code, you will get the great discounts, and साथ में मेरा पूरा guidance आपको भी मिलने वाला. That is BVReddy. Right. This is the 2025 electrical के लिए. And the plus class features you can see now here. Raise the hand options, class doubts, in-class polls, daily problem discussions, DPP, communities, learn from comfort of your home, study material, unlimited access to all the courses, and top educators. Next. And you can plan your Unacademy subscription with a no cost EMI also. Without paying any additional charges, you can able to avail these opportunities. And the daily scholarship test is there, and this is one of the great opportunity to all of you. The fellows who got the rank 1 in the scholarship test, they will get the 50% of discount. Yes, 50% of discount. This is one of the great opportunity. Try to enroll for it immediately. चलो, आज का सेशन हम शुरू करेगा. And the last class we have completed some of the problems. Let's finish the remaining problems. All of you do share to all your friends. Ask them to join in these sessions. How many problems we have completed yesterday? And we'll continue the remaining problems. Yes, take this thing. 10 problems we have completed now. Chalo, take the next one, 11th problem. Have a look at now here. Consider the circuit as shown in figure 1. The sum output of a off adder is connected as a clock excitation for Johnson counter. The input waveforms at X and Y are shown in figure. X and Y has been given. They ask him to find the number of state transitions at Q1 over the durations of capital T. So that means in this time period, they ask him to find how many transitions are there for what, tell me, Q1. As we know, this is given a 3-bit Johnson counter. ये कब काम करेगा? जब भी clock मिला तो तभी ये काम करेगा. So now let's identify this thing. Clock कब मिलने वाला? We'll see this thing here. So you can see now here, whenever the sum, this is the sum output is given now, and sum which is given as what I can say here, X, X or Y. Let's tell me now when the output is 1 here, when the different input case output 1 होगा, and you can see now in this case, so here इसमें this is यहाँ तक output is 0. In this region में output क्या होगा, tell me now, 1 बनेगा. In this region this is 1 and this is 0, so that means 1 time is 1. Next इधर 1. इसमें here you see this thing यहाँ से यहाँ तक, so both values are 1 only, so then output क्या बनेगा, इसमें 0 बनेगा. इधर this is 1 and इधर this is 0, so क्या बनेगा, this is output इधर 1 होगा, इसमें 1, this is 0, इधर 1 बनेगा. इसके बाद इधर क्या होगा, टेल मी नाउ, इधर इस यहाँ तक it will be 0 बनेगा. नेक्स्ट इधर इसमें यहाँ तक this is 1, so this is 1 होगा. यहाँ से यहाँ तक you can see now here both are 1, 0 होगा. इसमें this is 1, this is 0, so output 1 बनेगा यहाँ तक, and इसमें 0 होगा. Now इसमें क्या है, tell me now, this is 1 बनेगा, this is 0 and this is 1. And इसमें क्या है, tell me now here, इसमें भी 0 होगा and इधर again फिर से 1 होगा. You can see now how many times the output is 1, you tell me. 1, 2, 3, 4, 5, 6, 7. 7 times the output is 1, first of all. 7 times the output is 1. 7 times output is 1. That means 7 clocks will be going to here. Now they given this is a Q0, this is Q1 and this is Q2. And can you tell me now the working of the Johnson counter? That is Q2, this is Q1. Yes, सबसे पहले, so all the states are resetted at the rising trigger. So this means 0, 0, 0 initially when there is no clock. When you apply first clock, this is 1, 0, 0 बनेगा first clock पर. Second clock पर, so this is 1, 1, 0 होगा. I hope all of you know the working of a Johnson counter. कोई डाउट हुआ तो बोलिए, so then I will explain about the Johnson counter कैसा काम करेगा. 1, 1, 1, 0, 1, 1. So this is 1 clock and this is the second clock, third, fourth. Abhi this is what, tell me now, 0, 0, 1, fifth clock पर. Sixth clock पर 0, 0, 0, sixth clock पर. Seventh clock पर 1, 0, 0, seventh clock पर. अभी हमने क्या देखना पड़ेगा, you tell me. 7 clock pulse, how many transitions are there in Q0 पर, sorry, Q1 पर. How many transitions are there in Q1 पर, how many transitions are there, you see this thing here. These many transitions are there, you see. This is Q1. How many transitions are there, you can see. At the rising edge only ना. How many transition आपको दिख रहा कि नहीं, बोलो everybody. And so the option is what we can say, 3 transitions are na? Sorry, how many transition we need to see na? So here you tell me now, here this is one transition. Transition means change देखना पड़ेगा. So this is एक बार change हुआ, इसके बाद दिस इज कंटिन्यूसली 1 1 1 1, इधर आने के बाद और एक बार चेंज हो गया कि नहीं. सो हियर इसके बाद देयर इज नो चेंजेस. कितना ट्रांजिशंस है, टेल मी दैट. केवल 2 ट्रांजिशंस. ट्रांजिशन दे आस्किंग ना, दे आर नॉट आस्किंग हाउ मेनी टाइम्स आउटपुट इज 1. Transitions mean change. How many times the output is changes. How many times output changes is different. How many times output is 1, that is different. Okay. Completed. Shall next problem. And take this thing here. The initial content of the below shown 4-bit shift register is 0 1 1. Okay. Now they're asking the number of clock cycles required to get the same content. इसका मतलब what we need to find, you tell me. मॉड नंबर चाहिए. सो हियर ये वापस आने के लिए हमको कितना मॉड नंबर चाहिए, दैट वी नीड टू फाइंड आउट. ठीक है, हाउ मेनी टाइम्स वी नीड टू डू इट. ठीक है. सो आई विल फॉर्म ए टेबलर फॉर्म हियर. सो दिस इज माय क्लॉक. आई एम कॉलिंग दिस इज सम Q3, Q2, Q1 and Q0. So you tell me now here Q3, Q2, Q1 and this is Q0. Tell me now here. So initially when the clock is equal to 0, all these values are given as what? Initial state is given as what? Tell me. 0 1 1 1. Now tell me now, first clock हमने अप्लाई किया. So this is XR between what to tell me now? Q3 and Q0. इसका दोनों का XR किया. When the output of XR is 1, अलग inputs, different inputs के लिए. So tell me now 0 1. So it is what? Tell me 1 इधर आएगा, ये 0 shift होगा 1 1. And second clock अप्लाई किया तो so this is 0 1 0 1. थर्ड क्लॉक पर बोलो क्या आएगा? 1 0 1 0. फोर्थ क्लॉक पर so this is tell me 1 1 0 1. फिफ्थ क्लॉक पर 0 1 1 0. सिक्स्थ क्लॉक पर 0 0 1 1. समझ में आ रहा सभी को? सेवेंथ क्लॉक पर 1 0 0 1. एट्थ क्लॉक पर 0 1 0 0. नाइन्थ क्लॉक पर 0 0 1 0. भैया अभी तक नहीं मिला? यस. 10 क्लॉक पल्स 0 0 0 1. 11th क्लॉक पर 1 0 0 0. 12th क्लॉक पर 1 1 0 0. 13. Tell me what I will get now here. 1 1 1 0. 14. So 1 1 1 0. Sorry. 1 1 1 1 now. 15. So what I will get? Tell me. 0 1 1 1. ये वापस ये आया ना, this is the initial state is we got it ना, जो initial state is given as a 0 1 1 1. So अभी भी same आया ना, when we got, you tell me now here at the 15, after 15 clock pulses हमको मिला. So how many clock pulse required, you tell me now here, that is 15 clock pulse are required to get back this original. Done. Like this type of problems are very important. We expect this type of questions. Very frequently we can expect this type of questions. Chalo. Next. Take this problem. Tell me now here. They given the clock frequency given how much given here? F clock is given as a 160 kilohertz. Now they ask him to find the what is the output frequency. Now they given this is a 10 bit ring counter. Tell me now 10 bit ring counter. What could be the output, you tell me here? 10 bit ring counter. Ring counter, what is the mod number of a ring counter? N. The mod number of a ring counter. Odd number of ring counter. In case of n bit case, which is equal to n. And mod number of a parallel counter. Parallel counter means what? Tell me synchronous counter. Parallel counter means what? Tell me synchronous counter. Synchronous counter. How much, you tell me? 2 power n. Not mentioned, we'll take it as a binary counter. Means all the states will count. And mod number of Johnson counter. Odd number of Johnson counter. How much, you tell me? That is 2 into n. Johnson counter mod number is 2 into n. So you tell me now here this is f clock. So tell me now here the output frequency, what will come, you tell me? F clock by mod number is 10. And so this is what, tell me here? And f clock by, so this is what I can say here, 10 into, this is 2 power 4. That means 16. Now this is 25 already given. So means what I can say here, the mod number, what I can say, tell me? F clock by 10 into 2 power 4 16 into 25. Mod 25 is mentioned clearly. And the Johnson counter mod number is what, tell me? That is f clock by 10 into 16 into 25, and the mod number of Johnson counter is 2n. So this is into 8 now. 2 into 4 bit counter. So it is a 8. So you can tell me now here how much will get now. They given f clock is given as what, tell me? 160. So that is 160 kilo. This means we can say this as 1000 by, you can see now here 25 into 8, so that is a 200. So how much will get to tell me now? 10 into 16 into, so 25 into this is 200. So कितना आएगा बोलिए? So this is 160 will get cancelled, two zeros get cancelled, and this is two fives. So how much? Tell me now. 5 hash. Got it? All of you do like the session and share to all your friends. Do like the session and share to all your friends. Academy पर मेरा क्लास शो नहीं हुआ. कौन सा क्लासेस? Which classes you are talking? Sharma, regarding what classes you are talking? Special. You are talking about the this is upcoming, the special class series you are talking. Free वाला. So you can check यार. नहीं देखो एक बार मेरे प्रोफाइल में चेक करो. हाई यार, हाई एक बार चेक कर लो. हाई चेक कर लो, मेरे प्रोफाइल में चेक करके देखो. ये क्लास नहीं होगा, ये क्लास नहीं होगा, ये केवल यूट्यूब पर. दिस क्लास इज ओनली यूट्यूब में. सो हियर टुडे, yesterday I told you ना, digital Barfi series 1 2 3 YouTube. 1 2 3 it is in YouTube. So this is, you can see this thing, series 1, series 2, series 3. These classes only YouTube. Only YouTube you will get. These are YouTube classes. These are YouTube classes. Next, and from the 4, 5, 6 are there now. This is from the 4th November. 4th November and 5th November and 6th November. These classes are in special classes app. Special classes, and these are on app only. These are app. Okay, thereafter I will plan again. The remaining classes will be in the special classes. First 3 classes only on YouTube. The remaining are in the special classes only. Okay. Next, yeah, take this thing. Take this problem. Consider the partial implementation of a 3-bit mod 8 up counter as shown below. To complete the circuit X should be. For this they are asking what will be the X value. So this thing they are asking. So what we need to do here, we need to design it. We need to design करना पड़ेगा, isn't it? So tell me now how we can design now here. हमको केवल ये चाहिए. What type of counter is it? This is the synchronous counter. Synchronous counter के लिए हमने पूरा टेबल बनाना पड़ेगा. So how we need to form a table? You tell me now here. This is the present state. and this is a next state and the flip-flop inputs. Present state, next state and the flip-flop inputs. The present state, present state, which I am calling this as what, tell me here. So here this is Q2, Q1 and this is my Q0. And the next state means what we can say here, I am calling the next state Q2 plus Q1 plus and this is Q0 plus. Flip-flop inputs, what I can say here, T2, T1 and this is T0. Right. Now you can see this thing here, X value means T2 design karna. They are asking what will be 3-bit mod 8 up counter. So you can see this thing, we need to design a mod 8 up counter. Agar if I say the present state is 0 0 0, so the next state क्या है, tell me, 0 0 1. अगर present state is 0 0 1 है तो इसका next state क्या है, 0 1 0. If it is so 2 है तो the next state is 3. If I say this is 3 I तो the next state is 4. And for this 4 next state is 5. 5 the next state is 6. 1 1 0 for 6 next state is 7. 7 के बाद हमको क्या चाहिए, next state is 0 0 चाहिए. This is the thing we required, right? So now you tell me now here T flip flop हम डिजाइन करना पड़ेगा. हमको केवल क्या चाहिए, T2 चाहिए, हमको केवल T2 चाहिए. तो उस पर फोकस करो. हमने एक्साइटेशन टेबल ऑफ T flip flop हमने कुछ बोला. So that is what we can say here, Q plus which is equal to T XOR with Q. अभी हमको the XOR will have one special property. If we know that T and Q, we can get Q plus by simply taking the XOR. अभी हमको क्या चाहिए, T चाहिए ना. So T is equal to what I can say, tell me, Q XOR with what, tell me now here, Q plus. Right. Now you can see now XOR between what now here, this and this. 0 XOR is what, tell me, 0. 0 0. This is 0. 0 0. XOR is 0. 0 1 1. 1 1 0. 1 1 0. 1 1 0. 1 0. This is 1. And you can see this thing T2 हमको केवल T2 पर फोकस करो. T2 which is 1, इधर 1 हुआ ना, this is one min term, ये भी min term है ना. So this means what I can say here, T2 which is equal to what, tell me now, min terms, Q2 bar Q1 Q0 plus Q2 Q1 and this is Q0. You can see now I can take out what, tell me now here, Q1 Q0 common. So which we will get it as what, tell me, Q1 Q0 will come now. So comes the option, you tell me, option C. Done. Next one. Yeah, tell me the next one. Yeah, this problem हमने अभी भी किया. Just now we did this thing now here. Now tell me now here इसका आंसर बोले जल्दी फटाफट. Now so this is रिंग काउंटर. रिंग काउंटर का मॉड नंबर कितना? n. अभी ने देखा ना, रिंग काउंटर का मॉड नंबर इज n. So here this is, if I call this is my f clock, here what I can say, this is f clock by 10 mod number, and this is a 4-bit counter. So 4-bit ripple counter. Mod number is ripple counter means asynchronous counter. This is what tell me, asynchronous counter. Mod 16 given. So what I can call, you tell me now here, f clock by 10 into 16. Ripple counter now mod number given, mod 16 counter. And this is whatever Johnson counter mod number is, how much you tell me, 2n. Ring counter ka mod number is n. So this means what I can say here, f clock by how much here, 160 into 2n means 10. How much the input clock frequency given as a 200k, 200 into 1000 by what I can say, tell me, 160. अभी देखो 2 zeros cancel हो गया, and this is 2 8s. So then simplify, how much will get now, 8 125. So कितना आएगा, tell me now here, 125 hertz. Got it? La 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 la. Next problem. Now take this problem. Shall we start this thing? Yes. The problem, see the logic now, what they given. Consider the sequential circuit shown below. The output Z becomes 1 after n clock cycles. Then they ask you to find the value of n. That means indirectly they ask you to find what, tell me, mod number. Isn't it? Indirectly they ask you to find what, tell me, mod number they ask you to find. That's all. Output is, now you see this thing here, z is equal to 1. So when it is happens, tell me, this is the AND gate. So means all the input must be 1. So means this value must be 1, this value 1, this value 1. ये this value 1 है तो this value तो 0 होना पड़ेगा. Yes or no, this values must be 0 होना पड़ेगा, तभी ये 1 बनेगा. ये लॉजिक समझ में आया? And the flip flops are given JK flip flops. Flip flops are JK flip flop. So it is थोड़ा simplifications ज़्यादा होगा. Carefully हमने टेबल बनाना पड़ेगा. Right. Look at now here. Here they given j naught given as 1, k naught given as 1, j naught equal to 1, k naught equal to 1, and j1 which is equal to what, tell me? j1 कहाँ से, q2 बाद से आया, q2 bar. Next k1 is what, tell me? 1. Next j2, you tell me. j2, this is q1, k2 1, k2 value 1. So abhi bolo, this is what I can say now. Here we will get this outputs are q now, this is q1 and this is q2. समझ में आया सभी को this table? Right. Now you can see now initially, now when this all values are 0 0 0, then this value 0 means z value 1. Now we need to see when again all values are 0 0, वो देखना पड़ेगा. So j value 1, j naught, k naught is 1. Tell me now q2 bar means 1, this is 1. q1 is what, tell me? 0, this is 1. 1 1 means what, tell me? Toggle. 1 1 means toggle. 0 1 means JK flip flop is reset. Got it? Next, this is 1 1. q2 bar, so this is 1 1. q1 is 1 1. So this is a toggle AB toggle I. Right, next, this is 1, this is 1. q2 bar means what we can say? 0, this is 1. q1 is 0 1. So toggle, this is reset, OB reset I. Next 1 1, q2 bar, so this is 1 1. q1 is 0, this is 1. Toggle reset 1 1. q2 bar, so this is 1 1. q1 is 1 1. Abhi this is a toggle, this is toggle OB toggle I. Next 1 1. q2 bar is what, tell me? 1, so this is 0 1. q1 is 0, this is 1 1 1 means toggle, 0 1 means reset, 0 1 means reset. Yeah, you can see now here in this situation all these values are 0 means, so this bars complements are 1, then output z is equal to 1. So you tell me now after how many clock pulse, you tell me here. This is a first clock pulse, second, third, fourth, 5 and 6. So after 6 clock pulses a 1 banega. So mean this is the mod 6 up counter. Then a 2 megahertz clock signal is applied to a JK flip-flop with J equal to K equal to 1. The frequency of output signal of the flip-flop is equal to, tell me, they given this on JK flip-flop, J is equal to 1, K is equal to 1. So, agar J is equal to 1, K is equal to 1, that is called as a toggle mode. Now tell me, JK, so then output to toggle banega ki nahi? So here if the F clock input frequency, now what is the output frequency? You tell me now. F clock by 2. So J is equal to 1, K is equal to 1. That is what we will call, you tell me. That is a toggle mode. Right. So F clock by 2. So how much will get, you tell me now here? That is, yeah, 2 megahertz by 2. But they ask in the kilohertz में पूछा ना, so this means what we can say here, 1000 kilohertz. So how much this value? 1000. Next. And this is the state machines. Mealy or More state machines. They ask him to find the sequence detector of what, tell me? 110 का sequence detector. Tell me now here sequence detection 110 के लिए क्या है बोलिए? 110 we should implement now here. So here अगर 0 आए तो वापस आएगा. सबसे पहले देखो इधर चलेगा ऑप्शन ये. 1 आए तो आगे बढ़ेगा. यस. अगर नेक्स्ट 1 आए तो ये भी आगे बढ़ेगा. अगर नेक्स्ट 0 आए तो आगे बढ़ेगा. एंड दे गिवन दिस एज व्हाट टाइप ऑफ सीक्वेंस नाउ हियर. नेक्स्ट अगर इधर 1 आई तो इधर किधर आएगा? नो, सेल्फ लूप बनाना पड़ेगा. सेल्फ लूप नहीं है. सो यू सी ऑप्शन सी. चेक करो. Isn't it? Got it? Next one. Consider the circuit shown below. The value of the Q2, Q1, Q0 after first clock pulse equal to. After one clock pulse, they are asking the value. They are just asking one clock pulse, so no need to form a table form. Initially, सारा value 0 दिया. So means this value 0 ना, mean this value 1. 0 and this value 1. And this is 0 and this value 1. ठीक है, first thing. Now अभी inputs ध्यान से देखना पड़ेगा. So a 0, so 0 will come to here I am. And this 1 will come here. Okay. Now this is 0 and this is 1 and this is 0, this is 1. Is this point clear? You tell me. अभी ये इसको रिमूव किया मैंने. ये क्लॉक पल्स अप्लाई करने के बाद you tell me now here Q2 and this is Q1 and Q0 क्या आएगा चेक कर लो. ये क्लॉक पल्स करने के बाद so you can see now here 1. So this is a set बनेगा. 0 1 बोले तो रीसेट होगा. 0 1 बोले तो रीसेट बनेगा. So सो आफ्टर 1 क्लॉक पल्स क्या होगा, टेल मी, 1 0 0 बनेगा। चलो नेक्स्ट में, a 3-bit triple counter is to be designed as a mod 4 counter. What is the best architecture of logic gate? A 3-bit triple counter is to be designed as mod 4 counter. Now they ask him to find the best architecture, they ask him to find. Tell me now here. They ask him to find a mod 4 counter. That means how many states required now here? Shown below. This is what type of counter here? Now, you can tell me now, first of all, mod 4 counter, how many states required? First of all, you tell me now, this is a asynchronous counter. This is a asynchronous counter, first thing. This is up counter, down counter, you tell me now here. That is q into negative trigger ना, that is minus q. अभी बोले तो कौन सा स्टेट में आए ये फेलो, दुख में आई, एंड दुख के बाद क्या आएगा, टेल मी, सुख आएगा. दैट मीन दिस इज व्हाट काउंटर, यू टेल मी, अप काउंटर. दिस इज अप काउंटर. अप काउंटर, हाउ मेनी स्टेट्स आर देयर, यू टेल मी. पहले 0, 0 के बाद 1 आएगा, 1 के बाद क्या आएगा, 2, 2 के बाद 3. दिस इज अ मॉड 4 काउंटर, एंड 3 के बाद अगेन 0 आना पड़ेगा. जब भी 4 आया, दैट मीन्स क्या होना पड़ेगा, दिस इज Q2, Q1, Q0. जब भी 4 आया, तुरंत रीसेट को एक्टिवेट करना पड़ेगा, क्लियर को एक्टिवेट करना पड़ेगा. You see this thing here, a logic circuit क्या दिया, किसको दिया, you see this thing here. इधर यहाँ से कनेक्ट किया ना, ये वाला यहाँ से कनेक्ट किया, इधर यहाँ से कनेक्ट किया ना here. Only Q1 is given, sorry Q2 is given. So जब भी this is 1, ये तुरंत यहाँ से अगर मैं डायरेक्टली सीधा कनेक्ट किया तो क्या होगा, अगर मैंने सीधा डायरेक्टली इधर कनेक्ट किया तो हियर दिस इज 1 हुआ, 1 हुआ. जब भी दिस इज 1 हुआ, ये सारा फ्लिप फ्लॉप रीसेट बनेगा, वो चाहिए ना. सो इधर हमको कोई लॉजिक सर्किट चाहिए क्या, नहीं. नो नीड ऑफ एनी लॉजिक सर्किट, नो लॉजिक गेट इज रिक्वायर्ड. सिंपली डायरेक्टली हमने Q2 से डायरेक्टली इधर कनेक्ट किया तो सिंपली वायर कनेक्शन से हो जाएगा. Need of any another logic circuit. ये बात समझ में आया सभी को. चलो नेक्स्ट थॉट. A 4-bit synchronous up counter is holding a state of 0 1 0 1. What will be the count after 27th clock pulse? After 27th clock pulse के बाद काउंट क्या आएगा, दिस इज द 4-bit counter. So पहले initial state is given as this much. And the 4-bit synchronous up counter means 4-bit how many states are possible, 0 to 15 tak possible, 16 states possible. Now you tell me now here 0th clock, 0th state, tell me the state they given us. What, tell me here, initial clock they given, the state is given as 0101 diya, right? Now, can you tell me now after 16th clock pulse, at the 16th clock pulse, what will be the state? You tell me now. ये वापस वो आएगा 16th clock pulse. Now, इसके बाद अगर आपने नेक्स्ट 32 clock pulse क्या आएगा? ये भी सेम आएगा. That means what I can say here, 32 clock pulse same आएगा. Now we can call this as what, tell me now here, 32 second clock pulse 0101 आएगा. Yes, you can tell me now अभी हमने कैसा proceed करूँ. So this is at 32. So this is what we can say, 32, 31, this is 30, and this is 29, 28, 27. ऐसा मूव करना पड़ेगा. At the 32, how much this value you tell me, 5. So इधर क्या होगा, 4 आएगा. So we are moving reverse, we are moving. So this is a 3, इधर 2 होगा, इधर 1 होगा, इधर 0 होगा. Means at the 27th clock pulse ने पूछा ना इधर. At the 27th clock pulse, what is the state you tell me, 0. Means this is an option, now tell me. Okay. The following synchronous sequential circuit has dash number of states. How many states are present? That means mod number they are asking. So it is what type of counter, you tell me, synchronous counter. Synchronous counter के लिए कोई short trick नहीं चलेगा. हमने केवल पूरा टेबल बनाना पड़ेगा. And JK flip flop is given ना. So टेबल बना लो पहले. So J naught connections ध्यान से देखो. J naught is equal to what they given, Q1 bar. And the K naught is given as what, tell me, 1. And J1 connection देखो, Q naught. K1 connection is what, tell me, 1. Abhi this is what we can say, tell me now, Q naught. And this is Q1. Initially 0 0 मान लो, mod number चाहिए 1 1, this is 0 1. 1 1 बोले तो toggle reset. Q1 bar is 1 1, Q naught is 1 1. Toggle, ये भी toggle है. 1 bar, this is, so this is 0, this is 1. Q naught is 0, this is 1. So क्या है, tell me now here, reset, reset. ये वापस आए ना. So how many states are there? So this is the mod 3 counter. How many 3 states are? How many states are? Not 4 states. This is the mod 3. How many states are there? 3 states now, mod 3. Not. So see this thing here, 0. 0 के बाद हमको क्या मिला? We got it as a 2. 2 के बाद हमको 1, 1 के बाद क्या आया? 0 आया. So this is what we can say, mod 3 counter. How many flip-flops? Hmm? Okay, fine. Ulta लिखा है मैंने. Okay, so here this is the order. I have taken Q naught as a MSB. I have taken here. Okay, Q naught. So in the synchronous counter we cannot decide which is the MSB, which is the LSB. So जो चाहिए वो हम ले सकते हैं. So but asynchronous counter में, so we can say this as a LSB we can say. But here we can't say the what is the LSB. ठीक है. इधर हमने ऐसा ऑर्डर हमने फॉलो किया. सो दिस इज ऐसा ऑर्डर क्यू नॉट क्यू वन, ये ऑर्डर हमने लिखा. दिस इज व्हाट टेल मी 0 0 0 0 के बाद क्या आया 1 0 1 0 के बाद 0 1 0 1 के बाद ये आया. दिस इज द ऑर्डर आई रोट कंसिडर्ड. How many flip-flop would be complemented in 10-bit binary ripple up counter? Okay, this is what they given now here, up counter to reach the next count after this count. So here initially they given as 1 0 0 1 1 0 0 1 1 1 12-bit counter given. So 10-bit counter, 10-bit is given. Right. So what the next state now here tell me क्या आएगा 1 0 0 1 1 0. This next state will be 1 0 0 0 बनेगा. How many bits are complemented? You see this thing here, 3 bits. So now 4 bits complemented. 4 bits are complemented. How many bits are complemented? You can see 4 bits are complemented. Next. Try this thing. On the option. Option D. So everybody know this thing now. SR flip-flop का characteristic equation. SR flip-flop is what tell me. So Q plus, which is given as S plus R bar into Q, S plus R bar into Q. JK flip-flop tell me characteristic equation. J Q bar plus K bar into Q. Next, D flip-flop, which is given as what, tell me D only na, and the T flip-flop characteristic equation is what, tell me T XR Q. None of you right like this. We did these problems right. Fine. I hope all of you enjoyed the session. All of you do like the session, everybody. Do like the session, share to all your friends and save the link. And the 3 classes today, tomorrow, day after tomorrow. Yes, tomorrow we have a YouTube. And another thing is tomorrow's we have the class timings are, this is 8 p.m. Remember, tomorrow class timing same YouTube session only, that is 8 p.m. Continuation 8 p.m. Do remember, tomorrow not 6 o'clock, that is 8 p.m. 8 to 9. Okay, you can join the session tomorrow at 8 to 9 and the continuation of these problems we'll see. 24 problems we have completed now. Next remaining problems will continue tomorrow. All of you do join the tomorrow sessions. Okay then, see you, bye bye, good night.